Figure 17 shows the three components of the supersystem. These three components interact continually with each other. Figure 18 shows that the standard classical electromagnetic model and electrical engineering include the physical system, but exclude the other two components of the supersystem, being the active vacuum and curved space-time. Figure 19 shows the operation of a prior art electrical power system, where the operator inputs and pays for all the energy input. Performance of such prior art systems is limited to coefficient of performance less than 1. Figure 20 shows the operation of a prior art solar-powered electrical power system, enabling coefficient of performance equal to infinity performance. Figure 21 shows the two reservoir energy input system used in the prior art common home heat pump, and enabling coefficient of performance greater than 1 performance. Figure 22 shows the arrangement and schema for the operation of the invention in coefficient of performance greater than 1 but less than infinity operational performance mode. Figure 23 shows the arrangement and schema for the operation of the invention in coefficient of performance equal to infinity operational performance mode. Figure 24 shows the mechanism for amplification of negative energy flow in impedance section of the invention, when sharp gradients, pulses, are used. Figure 25 shows typical circuit elements that have impedance and exhibit environmental amplification of their negative energy flow, when sharp gradients, pulses, are used. Figure 26 shows a schematic of a first part of the system, being an inductance-coupled impedance matching oscillator trigger device. A trifiller inductive coupled transformer section also acts as a negative impedance and an environmental amplifier for negative energy, even though for positive energy it is a 1-to-1 type winding. The negative impedance freely receives excess negative energy from the active environment, so as to produce and amplify the input negative energy from the sharp gradients into greater negative energy pulses in the output. A full-wave rectifier keeps the amplified output pulses all positive above a reference zero axis. In this example, a 12-volt battery is used to power the trigger device. While a 12-volt battery is shown in some of the drawings, it is merely one preferred embodiment, or an example, as will be apparent to one skilled in the art after reading the descriptions. Other batteries could be substituted and other voltages used without departing from the spirit and scope of the invention. Figure 27 is an oscilloscope picture of the rectified above zero reference negative energy pulses that are output by the oscillator trigger unit in Figure 10, showing a rapid buildup and discharge of successive pulses, being part of the environmental operation providing amplification of input negative energy from the environment. Figure 28 is a schematic of a second part of the system, in one embodiment being a free-running 555 timing circuit that drives a high-voltage optocoupler for discharge of the high-potential charge in a capacitor across a series resonance circuit to at least one battery. In an alternative embodiment, a neon bulb can replace the timing circuit. Figure 29 is a schematic of the invention's high-voltage switching, environmentally amplifying, and battery charging operation. The silicon-controlled rectifier shown is mounted in inverted position, because of the use of negative energy. The battery part of the circuit receiving the negative recharging pulses is in floating ground condition and is isolated from the main grounding of the system. Figure 30 is an oscilloscope trace of the high-voltage switching potential across the battery under charge in its floating ground situation. Polarity inversion is used in applying the signal, because of the use of negative energy charging. Figure 31 is a schematic representation of the scheme or process for battery charging from an environmental source of high voltage. A capacitor is charged to high potential, and then this potential is used to furnish a sharp negative energy gradient across a receiving battery, from a switching, amplifying, and discharge circuit establishing the sharp gradients with the external environment so as to provide negative energy pulses of substantial negative energy and power. Figure 32 is a schematic for one embodiment for providing the necessary high potential from the external environment, with the high voltage potential being furnished by an elevated antenna of 200 feet in length, 30 feet above the Earth. This antenna taps into and intercepts the Earth to electrosphere potential, which is a normal 200 to 300 volts per meter. The connection to the high voltage capacitor, which may be of small capacitance, charges the capacitor to that potential between the antenna and the earth. The resulting pulses from the system establish the sharp gradients with the local vacuum potential and curved spacetime, thus providing an environmental amplifier for negative energy and a negative energy flow from said altered local environment into the system and across the battery, charging it with powerful pulses of negative energy. Note that the battery is isolated from the earth grounding of the system, and is on a floating ground. Figure 33 is a schematic for a full radiant battery charger and power supply embodiment using silicon-controlled rectifier in its switching circuitry. In this embodiment, the battery on the left side of the schematic is used as power furnishing battery, and it discharges electrical energy in normal positive energy mode to power the circuitry. In the output there are two additional 12-volt batteries as the load, and these batteries are being very rapidly charged by excess, amplified negative energy furnished from the altered local vacuum environment and local curvature of space-time. Figure 34 is a schematic for powering a monopole electrical motor by the full circuit shown in Figure 17. For continuous operation, the roles of the powering battery leftmost in the diagram and of a recharging battery to the right in the diagram can periodically alternate. In this manner, battery roles alternate between recharging and powering mode, so that a freshly charged battery is always powering the system, while two batteries are recharged quickly using highly amplified pulses of negative energy freely received from the external environment. In this way, the unit is a continuous power unit for the motor as the desired output load, which in turn powers a shaft load, which may be any normal shaft load used with electrical motors. This is a schematic for a self-powering system, freely powering itself and its losses and load with regauging energy freely received from its active external environment. Figure 35 shows an application system using earth cells with a potential switch and a transistor. Figure 36 shows an aspect of the invention in such a manner that the circuit's operation as an inverted potential switch can be better understood, considering also the use of negative energy rather than positive energy. The inverted potential switch can be further modified to optimize the receipt of negative energy through the E-amp effect. However, that will be the subject of a separate provisional patent application.